for constructing our units. From definition, the force between two masses, such as here and here, can be expressed this way. Force equals the gravitational constant G times m1 over r, m2 over r. We observe from this that mass is defined in terms of a linear density. So we conclude that any element with kilogram should be written as kilograms per meter. Okay, so that's our first rule. Okay. What are some implications of that? Let's look at joules. Units for joules would be kilogram, meter over second, squared. We would be writing that as kilogram per meter, meter over second squared, meter to the 1. Okay, and newtons, normally written as kilograms, meters over second squared, will now be rewritten as kilogram per meter, meter over seconds squared, meters to the 0. Power in watts will be written as kilograms per meter, meters over seconds cubed, meters to the 0. Now let's put some of these down. Power was in terms of joules, and we wanted kilograms per meter, meters over seconds cubed, meters to the 0. Energy. So put in energy? Yep. Okay. Energy will be in terms of kilograms per meter, meters over seconds squared, meters to the 1. Action. Oh, we haven't put that in yet. Okay, we'll get to it. Force is kilograms per meter, meters over seconds squared, meters to the 0. Okay, that's not a bad start. Now we can start filling the chart in by examining what's going on here. Okay, let's notice here, look at this column first, because it's a nice easy one. Every unit should start with kilograms per meter. That was one of our rules. Okay. Second thing we observe is the meters per second, the velocity is always squared in this column. Okay, the next thing we'll notice, this goes from 1 to 0 to the -1, -2. I'll extend it down this direction to an unnamed element. And so on and so forth. It would keep going down, and of course it would keep going up as well. The next one would be meters to the 2 power, but we won't bother writing that one in. Okay, now let's expand a row. Okay, here we see we have a kilograms per meter in both of these. We have meters seconds cubed and meters seconds squared. Our meters are climbing from 0 to 1. Okay, so our units would look like this. Kilograms per meter, meters over seconds to the 1, meters squared. And that tells us immediately that this one is kilograms per meter, meters over seconds to the 0 power, meters cubed. And then one to the right of it, just for grins, is kilograms per meter, meters over seconds to the 0, that would be -1, meters to the 4th. Okay, let's fill in the rest of these then. Same logic would apply here. Everything in this column should have meters over seconds to the 1st power. This starts at meters squared, so the next one down would be meters to the 1st. And then meters to the 0, then meters to the -1. Okay, let's fill in for moment. Kilogram per meter, meter over seconds to the 0, because we're following this progression. So let's put those in. And then we'll do the decreasing of the exponents for the meter part. Meters squared, meters to the 1st, meters to the 0. And indeed, you know, this one comes out just as kilograms per meter, which is exactly what you would expect from mu. Alright, and we'll fill in the last of these as well. These are meters per second cubed in this column. Meters to the -1, meters to the -2, meters to the -3. And again, we could go off this chart. This would be what, meters to the -4 and so on. Okay, and if we were to go over one row this way, we'd see from the pattern that it would be kilograms per meter, meters over seconds to the 4th, and meters to the -1. So it's fairly easy to expand this pattern once you get it started. Okay, I think we'll stop here.